Hello guys, this is Dev. Today I am going to continue with the part 2 of the MCQ series, okay? Alright, so this is the first question. A heavy particle of mass 0.5 kg is hanging from a string fixed with the roof. Find the force exerted by the string on the particle, okay? So you have to read the statement very carefully. You have to find the force exerted by the string, okay? And on the particle, alright? So you see, this is a very elementary question. I think all of you know the answer to this, but I'm just explaining to give you a very clarity of the concepts. You see, this is a string and this is a mass. First of all, you see mass is stationary. Okay, mass is stationary. First point. Now next point, what are the forces on the mass? You see, if you have to calculate forces on the mass, first isolate the mass and then now draw the diagram of the forces. First is the weight of the mass and next is the tension due to string. Okay, since mass is stationary, it is not accelerating, so A is 0. Okay, so this means the balance of forces mg minus t is 0. Since this means forces have been balanced, so mg would be equal to t. Alright, since this t is the force due to the rope, okay, due to the string, hence the answer would be mg, or you can say 0.5 into 9.8. Alright, this would be 5 to the 40, this would be 49 newtons. Okay, this is the answer. Very simple question, all of you know, but I am just wanting to clear one thing out, that if you want to draw the FBD, free body diagram, you have to first isolate the mass and then draw all the forces on the mass. Okay, you don't have to draw all the forces by the mass. Alright, and one thing, this is not 49, actually it's 0.5 over here, so it would be 4.9 newtons. Okay, it is 4.9. Alright, so this is the next question. A block of mass m is pulled on a smooth horizontal table. You see, concentrate on the words. This is smooth. This means there is no friction. Okay, by a string making angle theta with the horizontal as shown in the figure. If the acceleration of the block is a, find the force applied by the string and by the table on the block. You see, this question will clear your concepts. First you have to find out the force applied by the string and by the table on the block. Okay, alright, so this is the situation. The man is pulling the block at an angle theta with the horizontal. Okay, you see, I very specifically stated the word smooth, so I have written this down. Okay, you need to really pick up these words, because the surface can have friction. So first I write down what is given. The acceleration of block is given. This means the block is moving, it is not stationary. And next, to find, what I have to find, force applied by the string on the block and force applied by the table on the block. Okay, so we are to see the forces on the block. Okay, so first I isolate the block. Okay, what are the forces? This is the tension along this direction making an angle theta. Alright, there is the force by the floor which is normal, and there is the force due to gravity on the mass. That's it. These are the forces. Alright, since this block of mass is moving in this direction, this means there must be some force pulling this block towards this direction. Since we can't find any other force, we can resolve the tension. Okay, this means the horizontal component Tx is pulling the block and causing acceleration. This means Tx equal to m into a. Alright, what is Tx? Tx would be t cos theta is equal to m into a. T equal to ma by cos theta. Alright, this is the force on the block due to the string. Okay, so we have solved the first part. Now what is the force applied by the table, which is normal? So I need to resolve this. Okay, I cannot write n equal to mg because there is a vertical component of tension also involved over here. So this means if this is t sine theta, now I can resolve. I can sum up these two and equate to this. So n plus t sine theta would be equal to mg. What was t? T was ma by cos theta. This means this would become ma tan theta, right? Equal to mg, and this would be n. N would be equal to mg minus ma tan theta. This is the answer. Okay, So this is the force applied by the table on the block. So we have solved the second part. Okay. Alright. So the next question is, a body of weight W1 is suspended from the ceiling of a room through a chain of weight W2. Okay. Now the chain has weight. In the earlier examples, the string was massless. Now it is having weight. So it is asking the ceiling pulls the chain by a force. First option is A, second is W2, C is W1 plus W2, D is W1 plus W2 by 2. Alright, so this is the figure. You see, this is a chain of weight W2 and this is the mass of weight W1. What do we have to find is the force of ceiling on the chain. Alright, you see, this is a very simple question. Anyone can answer it. But I want to just, clarify our concepts. You see, what are we to find? That force of ceiling on chain. So on chain. So first we analyze the chain. Okay, we isolate the chain. Alright. Now I have isolated the chain. Now I want to find the forces on this chain. What are the forces? You see, there is one force. Let us call it, T. This is due to W1. I am writing this. T is due to W1. Okay. And this is the force F due to ceiling. Okay. This and another force is there. There is this gravitational force, weight of the chain itself. This is the force. Okay. So since the chain is stationary, this means the forces have been balanced. This means force due to the ceiling would be equal to the tension due to the weight plus the weight of the chain itself. Okay. Now I have written this in bracket. Okay, don't think it is multiplied. It is a function of W1. Okay, and this is this depicts that this tension is due to the weight W1. Now how do I find this W1? Because I want to find FC. Okay, force due to ceiling. So I analyze the block W1 now. What are the forces on this block? First force is the weight itself, and next force is the tension due to the string. Okay. So since this block is stationary, this means tension due to the string is equal to W1, right? Now you see, action is equal to reaction. At this point, TW1 would be equal to TS, alright? The force with which the chain is pulling the block is same as the force with which the block is pulling the chain, okay? Because action equals reaction, Newton's third law. Okay, so I have applied third law over here. Alright, so this means these two are equal. We can just put T of W1 as W1. So we have force due to ceiling would be W1 plus W2. Anyone could answer this question. This is a very simple question, but I just want you to know how to draw the free body diagram. Okay, this is the free body diagram of the chain and this is the free body diagram of the weight. You see, in this free body diagram of the weight, there is no involvement of ceiling. Okay. Some people write force due to ceiling also. This is wrong. Only the force's immediate vicinity or the pulling would be counted. So the pulling is wholly and solely due to the chain, not due to the ceiling. Yes, in the case of chain, ceiling is acting. Okay. Alright, so we move on to the next question. It is written, a block of mass M is placed on a smooth. You see, I am again emphasizing this word smooth. Okay, this means there is no friction. Inclined plane of inclination theta with horizontal, the force exerted by the plane on the block. So I want to find out the force exerted by the plane on the block. Okay. Alright, so we are given a smooth inclined plane and the block is lying on the inclined plane. What are we to find? We have to find the force exerted by the plane on the block. Okay. So first of all, I would want to know the forces on the block. So first I isolate the block. Okay. Obviously this is already isolated. Now, what are the forces on the block? First would be the gravity. You see, this is the incline. Okay, this means, this does not mean gravity will be like this. No, gravity will be downwards, mg, that's it. Okay, and the force of the incline would be, let us say this, normal. So since the force exerted by the plane is always perpendicular to the plane. Okay, if this is the plane, inclined plane, this means the force would be n and would be perpendicular. So we have the figure over here. Now we can start to resolve this. Okay, we can resolve the gravitational force along this line and along this line. Since this is smooth, this means acceleration would be due to this component of gravity. This component is mg sine theta. Okay, I have already explained why it comes out as mg sine theta. You can watch my previous videos. This would be mg cos theta. Now block is accelerating along this plane. Okay, so it is not undergoing acceleration perpendicular to this plane. This means perpendicular to this plane forces are being balanced. This means n equal to mg cos theta. Okay, so this is the answer. Okay, if we were to find the acceleration, that would have been mg sine theta equal to ma. Gets cancelled, g sine theta would have been the acceleration. So the force exerted by the plane on the block is mg cos theta. Okay, alright, so let's move on to the next question. The block of mass m is placed on a smooth wedge of inclination theta. Whole system is accelerated horizontally so that the block does not slip on the wedge. This means if I am an observer outside, I can see that the block is not slipping, the block is not moving, because the whole system is being accelerated. The force exerted by the wedge on the block. Now we have to find the force exerted by the wedge on the block. Okay, so we have the wedge here. Wedge is accelerating in this direction and the mass m is here. So as an observer outside, I can only see the mass going along this direction. The mass, the direction of the mass along the inclined plane is restricted. Okay, so this means it is differing from the earlier situation where the mass only went along the inclined plane. So what do I have to find? I have to now find the force by the wedge on the block. This means I have to find the normal force. Okay, if this is n and this is weight. Okay, earlier we saw that the block was going down the inclined plane because of weight. Now it is not going down. Why? Because there must be some other force countering the weight, and this force is now the component of the normal over here, and the other component is responsible for accelerating the block in this direction. So this was earlier theta. Okay, since this is 90 minus theta, this is 90 and this is 90 minus theta. So theta is contained between these two lines, so this is also theta and this would be n cos theta. So n cos theta would balance out the weight, since weight was the reason the block was going down the inclined plane. So n would be equal to mg by cos theta. This is the answer. Okay, so moving on, we have a force F1 acts on a particle so as to accelerate it from rest to velocity v. Just read the question very carefully. From rest to velocity v, it is given. The force F1 is then replaced by F2, which decelerates it to rest. Now we have to find the relation between F1 and F2. These are the four options given. So this is the figure given. We see that initial velocity of the particle is 0. Then force F1 acts on the particle and takes it to a velocity v at this point. At this point again, force F2 acts on the particle and takes it to rest at this point. Now F1, since it is constant, this means it will generate some acceleration. Let us say this is a1. So F1 equal to ma1. Now we have to find the acceleration over here. Since it has taken the particle from 0 to v, this means acceleration by standard definition is dv by dt. Since a is constant, because F1 is constant, so we have a dt equal to dv. We integrate this. Particle started from 0 and reached v from 0 time to t1, let us say. It took t1 time. So v would be equal to a times t1 and this is a1. Okay. So a1 is v by t1. So just we substitute this here. We have f equal to mv by t1. Okay. This is the expression for m1. Now for f2, particle is decelerating. This means initial velocity is v. Again we use this expression. We now take acceleration a2 because of f2. And this is not the acceleration, this is the deceleration. Alright. And f2 we can say is ma2. Now dv would be equal to a2 dt. a2 is constant as force F2 is constant. Now initial velocity is v, final is 0, 0. Now either we can take 0 to t1 because we are taking interval, okay, or from time t1 to t2, whatever suits us. Okay, so I can take, I take time t1 to t2. Alright, it started from t1 and now it is ending at t2. So we have minus V would be equal to A2 times T2 minus T1. Okay, this is the time interval, and we just substitute this here. We have F2 equal to M into T2 minus T1. Okay, and this would be minus, sorry, now I have to calculate T2 over here actually. So no, I have to calculate A2, right? So this would be minus V upon T2 minus T1. Yeah, this is A2. So now I'll put this expression over here. We get F2 would be equal to MV, and this is minus by T2 minus T1, right? So either T1 and T2 minus T1 can be equal. Alright, either these interval can be equal, T1 and T2 minus T1. If they are equal, then only we can say that F1 equal to F2. Alright, otherwise if they are not equal, then F1 is not equal to F2. So we have the condition here, T2 minus T1 should be equal to T1. Then only the forces will be equal. If this is not, then forces are not. So the second option was correct, that F1 may be equal to F2. Alright, so let's move on. You see, this is a question. A force F equal to V cross A is exerted on the particle in addition to the force of gravity. This means this is another force in addition to the gravity. Gravity is different and this is different. Okay, where V is the velocity of particle and A is the constant vector in the horizontal direction. Okay, so you see, it is not a vertical direction, it is only in the horizontal plane. Okay, in any direction in the horizontal plane it can be, it is not vertical. Okay, with what minimum speed a particle of mass m must be projected so that it continues to move undeflected with a constant velocity. You see, it is written here constant velocity. Alright, so this is the figure given. You see, this is the horizontal plane and this is the vertical plane. If I assume this particle has mass m, then gravity would act along the vertical plane, okay, not the horizontal. So gravity would be acting along this, okay, and it would be, minus mgk if I were to be exact. This would be the force of gravity, vector force of gravity. Now it is given that A is along the horizontal direction, right? This means A is along the horizontal plane, and now I have to project the mass m with such a velocity so that the force is balanced, because in the end mass is to move with constant velocity. Okay, if this constant velocity is v, then that means dv by dt is 0. This means net acceleration of the particle is 0. This means the net external forces acting on the particle should balance out. Okay, should be 0. Net external forces vector should be 0. So how do I do this? You see, it is given in addition to gravity there is another force F equal to V cross A. Alright, so what is the minimum speed with which the particle should be projected so that it moves with a constant velocity? Now I assume vector over here, A vector along this AJ. Okay, I can assume this because this is also horizontal. This plane ABCD is horizontal plane. Anywhere A vector along this plane would be termed as horizontal. Okay, because this is not vertical. Okay, and I will project the mass m along I with a velocity v. Okay, v would be, say, vi. Alright, so what will be the force now? F was v cross a, right? So this would be vi cross aj. Alright, this would be va I cross j, and this is F. What is I cross j? You see, according to right hand screw rule, if this is I and this is j, I cross j is positive k. Alright, I cross j is positive k. Okay, right hand screw rule states that we should move anti-clockwise, and the thumb and the direction in which the thumb points gives the direction of resultant vector. So if I am doing I cross j, I have to move this to the anti-clockwise, so it will give the above k, positive k. This means F is equal to VA k. Okay, this is the force. Now this force has to balance balance with the gravity. So this is F now. Okay, this is Fg. So this means net sum of external force F plus Fg should be 0. Okay, for the particle to move with a constant velocity, since dv by dt has to be 0. Alright. So what is F? F is Va k. Okay, what is Fg? Fg is minus mg k. This is 0. So we can take k vector outside. K vector cannot be 0. So Va would be equal to mg. Alright. So V would be equal to mg by. This is the answer. V is equal to mg by. This is the minimum speed. Okay, and along I direction, when the A vector points towards J and IJ plane is horizontal plane. Okay, and where the gravity acts is a vertical axis. It is not the horizontal axis. I and J here are horizontal axis. Okay, so V equal to mg by is the answer. Alright, so let's move on. We have two blocks of equal mass m. Okay, mass is equal, are tied to each other through a light string. Okay, this means the string is massless because it is light. We can assume the string to be massless. Okay, concentrate on the small words. Okay, and one of the blocks is pulled along the line joining them with a constant force. You see, the force is constant. Alright, find the tension in the string joining the blocks. Okay, so this is the figure. You see what is given. Given that string is light, this means string is massless and F is constant. Okay, so we have to find the tension between the blocks. So what we do first is we isolate one block. Okay, I have isolated the first block. Okay, now I want to find out the forces on this block. On this block will be one force is F and other is the tension due to the string due to M, the other M. Alright, so these will accelerate. Okay, since force is constant, acceleration will also be constant. So F minus T would give MA. Alright, F minus T would give MA. Now the second block I take, this would be experiencing a force of T. Alright, there is no force F over here, only T. The immediate vicinity of the external forces is taken. Okay, so T would be equal to mass into acceleration. Okay, T would be equal to MA. Now since the string is light, the two blocks will move with the same acceleration. Alright, if this block, if this block displaces a distance x, this block, for example, if this block displaces a distance x1 over here, this block displaces a distance x2 over here. Alright, and this is the length of the string. Now after displacement, what will be the length? You see, after displacement, for example, these are 2 points, M, and this is L. Now if this point goes up to here, okay, this is displacement of x1, and this point goes up to here, this is displacement of x2. So the length of string will be this now. Okay, the length of string will be this would be M and this would be M. So what will be the length now? Length would be x1 plus L minus x2, right? X1 plus L minus x2. This would be equal to the original length of the string, as string is light and string is inextensible. Okay, LL gets cancelled out, x1 equal to x2. Displacement of the blocks are same, hence the double differential of displacements would be same. Alright, so A1 equal to A2 equal to A. So here we have, okay, so just we add this, we have F equal to 2MA, A is equal to F by 2M. We substitute the value of A over here, we get T equal to F over 2. T is equal to F by 2 is my answer. Okay. Alright, so the next question is, two objects A and B are thrown upward simultaneously with the same speed. Okay. The mass of A is greater than the mass of B. Suppose the air exerts a constant, you see it is written constant and equal force of resistance on the two bodies. We have to find the correct option. First option is the bodies will reach the same height. Second is A will go higher. Third is B will go higher. Or fourth is any of the above three may happen depending on the speed. Okay, you see this is the figure. Now it is given that two bodies of mass equal and equal velocities are thrown up. Okay, you see it is given that force of air on both the bodies is F. Let us say it is F, because it is not depending upon the mass, but mass of A, now it is given that it is greater than the mass of B. Okay, so how do we do this? First of all, we see that there is an addition force in addition to gravity, which is the force of air resistance. Okay, if it was not there, what would have happened? Some other thing would have happened. Since velocities are same, for example, let us say this is mass A and mass B, masses would not have come into play, because at the end final velocity would have been 0, so V minus GT would have been 0. Okay, since we are taking this with respect to equation of motion, so G is along the opposite side. Okay, so V minus GT would have been 0, and finally it would have come down after stopping. Okay, so time would have been equal, V by G. Since time is equal, this means the height reached would have been same, because V square would be equal to U square minus 2GH. Alright, final velocity is 0, U is V here, so actually this is V final, U initial, UI is V. Okay, so V square by 2G would be the height. But here now we have force of air resistance also, so this changes our calculation. Now what happens is that F gets added with the gravitational force and then produces a final decelerating force, which would be ma. For example, for A, this would be ma times acceleration of A. Alright, so here acceleration of A would have been F by ma plus G. Alright, obviously in the negative direction. Okay, so now we would have said that V dV by dx, this would be equal to F by ma plus G, and this would be V square minus, we integrate, now we have V square minus U square equal to, since this was in the negative direction, so we have minus F by ma plus G into H. Final velocity was 0. Okay, initial velocity, this is V final, this is UI. Vf was 0 because the bodies will stop ultimately. So H we have here V square by F by ma plus G. Alright, so this we have. Okay, and in the this is the height reached by A. In the similar case, height reached by B would have been V square by F by mb plus G. This would have been the height reached by B. Okay, so you can compare the two. You can easily compare the two and arrive at a height. Since acceleration, or we can say deceleration, since mass is bigger, deceleration will be less. Since mass is bigger, the numerator by denominator, if denominator is bigger, then it reduces the fraction. This means the deceleration will be less in case of A. This means the deceleration of A is less than deceleration of B. So since deceleration of A is less, this means A will reach a more height than B. Okay, so height reached by A is greater than the height reached by B. This is the answer. Alright, so we have another question. A rod of length L is placed along the x-axis between x equal to 0 and x equal to L. It is given that the linear density, which is mass per unit length, and it is given rho of the rod varies with distance x from the origin. Okay, just remember this is varying from the origin as rho equal to A plus bx. Find the SI units of A and B. Anyone can calculate this. This is stupid question. Find the mass of rod in terms of ABL. Now we have to calculate this. Okay, mass of rod. First part I'll leave it to you. Okay, next part I'm doing, find the mass of the rod. Now you see it is given rho of x equal to A plus bx. Okay, this is the rod, and rho is the linear density, which is mass per unit length. One thing I get out of this is that mass is varying with length. Okay, mass is varying with length. This means any mass if I have to take, I have to take in terms of length, okay, and multiply it with a constant density, so we get the element mass. For example, if I take the element mass over here, this is my element mass. For example, this is dm. I take it at a distance x, okay, and the width of this element mass is dx. Now what would be the mass dm? Dm would be equal to rho times dx. Why dx? Because the length of the element mass is dx, okay, and it is taken from the origin at a distance x. Alright, so dm was rho dx, okay. Now what is rho? Since we have taken the dm at a distance x, this means rho is varying with x, so we have a plus bx, okay, rho, and we multiply it with dx and we get dm, okay. Now we have to integrate it. Now what are the limits? You see, I have taken the mass from the origin, so I have to start from O and end up to L, okay, and this would be 0 and this would be m, so m would be equal to ax plus bx square by 2, and now I take the limit 0 to L, so we have AL plus BL square over 2. This is the mass m, okay. This is the mass m I have with me. Alright. What would have happened if I would have taken the rod from L to 2L? Nothing much. We would just have changed the limits, okay. Here it is 0 to L. In other case, I would have taken the limit from L to 2L, okay. Same integration and the answer would have been different, alright. So the next question is, momentum p of the particle changes with time according to the relation dp by dt equal to 10 plus 2t. If the momentum is 0 at t equal to 0, what is the momentum at t equal to 10, okay. So this is very simple, you know, you directly integrate this. Dp would be equal to 10 plus 2t times dt, and now we can integrate this. This would be 10t plus t square, alright. And just put the limits. When 10t plus t square would be there, we put 0 to 10, right? 10t means 100 plus 100. This would be 200. Alright, whatever. I mean, you please calculate it, and this is very simple, okay? So the next question is, find the area bounded by the curve y equal to e to the power minus x, the x-axis and the y-axis. Alright. Alright, so y equal to e to the power minus x. First of all, I want to find out, this is the x-axis and this is the y-axis. Okay, so it is written that the area has to be found out between the curve, the positive x-axis and the positive y-axis. This means in the first quadrant, okay. And now, what is the curve in the first quadrant? First of all, when x equal to 0, y would be equal to e to the power 0, which is 1. This means here. And now, I would like to find out dy by dx so that I can find out if the curve is sloping downwards or upwards. You see, when we do dy by dx, we have minus e to the power minus x, right? Now, when is it 0? Well, at x when is it 0? Well, at x equal to infinite. This will be 0 at x equal to infinite, okay? Alright. Now, what is the double differential? D square y dx square would be equal to e to the power minus x, okay? E to the power minus x. This means, since e to the power minus x is always greater than 0, at infinity it will be 0, but it is always greater than 0, and dy by dx is 0 at x equal to infinity. This means that the curve will be down sloping and will reach a minimum at infinity, okay? So the curve would be like this, okay, a never ending curve trying to reach infinite, okay. Now I want to find out this area I have to find out, this whole area. So how do I do it? First of all, what I do is that I take a strip, okay. This has a coordinate y and this is at a distance x. This strip has a length of dx. Now what is the area of this strip? Obviously this strip has a breadth of dx and length is y, so y times dx. Area of a rectangle is y times dx, right? So just y was e to the power minus x times dx. This is dA. Now we just integrate this. This will be integrated from 0 to infinity. Alright. This will be 0 to a. Now what is this integration? This is minus e to the power minus x. This goes from 0 to infinite. So this will be e to the power minus infinity minus e to the power 0, and we have a minus 1 over here. So e to the power infinity is 0 minus 1 minus 1. This means area is 1. Okay, so A is equal to 1. This is the answer. Alright guys, I'm stopping here and I will be continuing with the question and answer series until you have a clear-cut grasp on the concepts. Okay. What I want to emphasize is that I want to clarify your concept so that if any question comes, you know how to solve it. Okay. And I don't know if there are any more videos that emphasize on this conceptual clarity. So I am doing this and I am taking the specific questions which emphasize on the concepts. Okay. Please subscribe, like, rate, review and recommend. Okay. Thank you.